Hey everyone, my name is Brandon Graisley. I'm a high school math teacher. We're going to start learning about sinusoidal functions, which are a special type of periodic function, and they show up a lot. This is pretty important stuff, so let's get started. You need to, first of all, already know about the unit circle. The unit circle was a way that we defined the sine and cosine functions for larger angles, things that were greater than 90 degrees. So before that, we had used primary trig. For acute angles, sine and cosine were fine, but once we got into big angles like the ones over here, starting at 0, going this direction, we had to define sine and cosine as the x value as this point moves around the unit circle. So let's imagine that point as it sort of cycles around in this direction, counterclockwise, repeatedly over and over again, and we're going to just use a calculator to figure out the values that sine and cosine of that angle would take on, the sort of x and y values at that point, and then we're going to graph those to see what the functions look like. So I've got on my page here these charts set up, angles going from 0 up to, on the second row here, 300, well I got to 390, a little bit past the full circle, and there's a row for cosine and a row for sine. So I'm going to fill those in right now, but I'm going to fast forward the video so you should try it yourself. Let me maybe just do the first couple with you. Make sure you're on the same page as me. So cosine of 0 is 1. Sine of 0 is 0. Cosine of 30 is, now this is written in a radical form. I'm going to change that into a decimal form because I want to graph it. It's very helpful to have these written down as decimals because it's pretty hard to know where to graph root 3 over 2. And I'm just going to use like 2 or 3 decimal places. That'll be plenty for the accuracy of my graphs. And sine of 30 is 1/2, which again I'm going to write as a decimal, 0.5. Okay, so you go ahead now too and go ahead and fill in all of these and make sure you also do 390. Okay, good luck. Okay, so I have my chart completed, and hopefully you saw the same patterns that I did. The numbers were repeating a lot in here, positive and negative versions of those exact same numbers, and cosine and sine sort of do opposite things, and they meet in the middle at 45, 135, and so on. So now we're going to move to a graph. We're going to plot all of these points, and then we're going to connect the dots to see how the curves look. Now, before we do that, I especially want you to notice that 390 matches 30. Exactly, the very same numbers. Let's go back to our unit circle to see why. 390 is the same as 30 degrees in standard position. That's one full rotation plus an additional 30 degrees. So 390 and 30 kind of look the same. They have the same terminal arm, therefore they have the same sine and cosine. And these values here are the same as these values here. That means this is going to be a periodic function. Okay, let's start graphing. I'm going to start by graphing sine of theta, and maybe I'll draw a scale on here to get us started. I want to have 30, 45, 60, 90. So let me see, if I went to 90 here, that's pretty good. Let's do that. 3 squares to get to 90. 180. 3 more would be 270. 360, and then that'll be 390 right there. So let me just put one more, 450. Okay, and then vertically, looks like I've got 6 squares here. Let's go to a nice number like 4 squares is 1, negative 1 down here, and so let me also label 0.5 and negative 0.5. Okay, so this is 30, this is 60, and 45 is going to be halfway in between. I'll be labeling or graphing points at the 45 mark. Okay, so we're going to start with sine. That's 0, 0, 0 for theta. Well, I should label the axes also here. This is the theta axis and the y-axis. So we've got 0, 0, and then at 30 degrees we're at 0.5. At 45 degrees we're at 0.707, so 0.75 would be here, so a little bit below that. 60 degrees is 0.866, so 75. It's very close to the middle of this. And then at 90 degrees we're at 1. So hopefully you can see that curve coming in there. And we're going to repeat the same numbers going downwards for the sine function. This is 150, and then halfway between we're there. And at 180 we're back to 0. Okay, so you should see like a little hill there. It looks like a parabola, but it's not a parabola. It's really similar. We're going to go downwards now. So 180, 30 after that is 210. So that's at negative 0.5. And then we have a point about there. That's the 707. 0.866 is right about there. And then negative 1 at 270. Now this level of accuracy that we're working with here, this isn't what you typically need when you're sketching these curves. So we don't do this all the time. 360 is back to 0, and at 390 we were at 0.5 again. Okay, so we have a large list of points here that we're going to try to connect smoothly. It's a little difficult to do on screen here, so please bear with me if it doesn't look awesome. I'm going to do my best. So first off, this part is almost straight here. Very close. And then it's going to start to curve. And it comes in flat here. Because it changes direction, it has to be flattened out. It's not pointy, it's nice and smooth, just like a parabola. And then it kind of straightens out again, because it's going to start to curve the other direction after we get through 180. This part is basically straight. It looks pretty straight. I'm going to come back up to the top here, draw a little flat spot there. So take your time. Maybe do this a couple of times. Now that continues straight through there, just like it does here and here. And you should put arrows on the end. And so that is y equals sine of theta. Now we're going to do the same thing for the cosine curve. Now for the cosine curve, at 0 degrees, cosine is at 1. And maybe this time I'm going to put in some key points. I notice that it's at 0 at 90. At 180 we're down to negative 1. See how this goes? 270, we're back up to 0. 360 up to 1. So those are some really key points, maximum and minimum points, the zeros or the middle values. And now I'm just going to fill in those extra little detailed ones. There's 30 degrees at 0.866. 45 degrees, just a little bit below 3/4. 60 degrees is at 0.5. Going past that, the same exact pattern as we saw with the sine function. And 390 is at 0.866 again. Okay. So you see we have the same pattern, kind of, it's in a different spot, but the same sequence of points in a different location. So let me just start drawing that curve now. Not quite as good. Now from here going to the left, this is going to return downwards. This descends again, just like it does on this side over here. Okay, and now we have y equals cosine of theta, and we can start talking about what these curves, how the characteristics of these curves, the properties of them, and the fact that they're periodic. So I have a chart that I'm going to fill out with a bunch of characteristics, and as I'm sort of going to flip it onto the screen as we go here, so please bear with me because I can't show you both things at the same time. So first of all, notice that the function repeats when we get back to 360, so that means the period of it is 360 degrees. So I'm looking at the sine function to begin with. The amplitude, it goes from -1 to +1, So that's the range of it. The amplitude is half of that distance, or from the distance from the center up to 1. So the amplitude is only 1. The maximum value is 1, and the minimum value is -1. So let me show you that. Now, to describe the domain, theta can be any real number. So theta is an element of the real numbers. You can write it like this, or you can put it here. It's the set of all theta that are real numbers. The range goes from, as we said, -1 to +1. Those are y values. So the set of all y values that are real numbers such that -1 is less than or equal to y, which is less than or equal to 1. Notice that we're using a less than or equal to sign because it does hit +1 and it does hit -1. What are the zeros? Well, we have 0, 180, 360, but that pattern also repeats in both directions. But that gives us a flavor for it. So what I'm going to do for this is the zeros, it's a large set, so I'm going to use a little brace again. Ellipses at the start to show that this is a pattern that continued to the left. 0 degrees, 180 degrees, 360 degrees, and so on. Notice the little commas there and there. Okay, so now let's go ahead and look at the cosine function. Well, here we have a peak, drops down to a trough, and then another peak at 360. So once again, the period is 360, the amplitude is 1, and the max and min values are 1 and -1. So a lot of similar characteristics. Period of 360, amplitude is 1, max is 1, min is -1. You can calculate the amplitude once you know the max and min values. Subtract those two things, you'll find a difference of 2. Cut that in half to get the amplitude of 1. The domain is also any real number. The range is also anything from -1 to +1. So wow, looking really, really similar here. These curves are almost identical. They're just in a different place horizontally. And so that affects where the zeros are. We have a 0 at 90. There's another one at 270. And after that, there's going to be something over here and something over here. So we do have zeros to the left. Let's list the ones we just saw, 90 degrees and 270 degrees. They happen every 180 degrees. So I'm going to add 180 on to get 450 to show that that pattern continues. And I could put -90 in here as well. That would be the first zero as we move to the left. Alright, let's learn how to graph multiple cycles in a row. And to graph each curve easily, you should plot the maximum points, the peaks, the minimum points or the troughs, and then the zeros. That's how we do it when these are in their sort of basic position. We'll learn later how to graph these when they're not in their regular spots, when they've been transformed. And after that, you just connect the points with a smooth curve. So I've got my graph paper ready here. I need to put a scale on it. I want to have multiple cycles, and I know that 360 is one cycle, so I want to have at least 2. So maybe I'll put 360 right there, and then if I go the same distance over here, that'll be 720 degrees. And working backwards, I'm going to write the same numbers in negative form, and negative 720 degrees, okay. And vertically, I want to go up to 1 and down to -1. It actually doesn't really matter where I put those as long as they match. So in between, I have 180 degrees, there's 90, and there's 270. I'm not going to label all of those throughout the graph because you're going to see this pattern is actually pretty easy. Let's start by graphing the sine function again. Sine starts at 0, 0. At 90 degrees, we get up to the value 1. So we're just going to plot the maximum points, the 0 points, there's one at 180, the minimum points, 270, and back to 0 again. See that pattern? Up, down, back to the middle. So middle, up, middle, down, middle. Then we go up. See, I don't even need to look at the scale here. I went 2 boxes over to get that peak, back to the middle, 2 boxes over to the trough, and back to the middle, and so on. Now working backwards, that was a peak, so this is going to be a trough right here. I used 2 squares on my graph. 0, maximum, 0, minimum, 0, maximum, 0. Okay, lots and lots of dots. I'm going to start connecting them now with smooth curves. Maybe I'll start here. That's a peak, so I want to kind of flatten that out on the top. Now if you want to get real accurate, you can try to find where 30 degrees would be. 1/3 of the way in, that's at a half. So if you can kind of aim for that, that's great. But you'll get used to just kind of doing this. So that's the kind of, that wasn't a great curve, but not too bad. That looks a little better. We're just trying to sketch here anyway, it doesn't have to be awesome. If you want a challenge, try doing this with a camera at the same time, suspended in your way. Makes it pretty hard. Okay, looking pretty good so far. Straight through there, curving in. I'm kind of aiming if you want. I'm aiming up here and then I'm curving in as we approach. So it's not a whole bunch of straight lines. It is all curved. And yours might look a little different if your scale is slightly different than mine. If you don't go up 4 squares, for example, the whole thing flattens out and it's a little bit easier, honestly. Okay, so at the ends, put arrows there and there to show that this continues forever, and somewhere you should label this. Okay, and there's our sine curve, and we've got many cycles now. I've got 1, 2, 3, 4, 5 peaks drawn and 4 troughs as well. So several cycles here for us to look at. Let's try the cosine curve. Once again, labeling, let's 90, 180, 270, 360, and from there if I hop over I'll get 720 going in this direction, negative 360, negative 720. That's the theta axis, and the y-axis 1, negative 1. Okay, plotting our points. Cosine starts at 1, so at 0 degrees we're way up here. A full cycle takes 360, so I know I'm going to get another maximum there. The minimum is halfway between at 180, and at 90 and 270 I get those zeros. So maximum, 0, minimum, 0, maximum. A little bit different from the sine function, which started on a 0 and went to a maximum, but from there it's the same. Max, 0, min, 0, max. You can see that that looks very much like this. Continuing from here, 0, minimum, 0, maximum, 0, and so on. Moving to the left, we're at a maximum, 0, minimum, 0, maximum. That's at negative 360. 0, minimum, 0, maximum, 0, and so on. Alright, let's see if I can do a better job connecting these curves. If you want, you can do a little thing like this. Put a little curve on every peak and trough. And then start connecting them. You get to the ends, put arrows on the end. These continue forever. according to those patterns. Okay, so some of those are pretty not great. This is kind of poor right here, but that one looks pretty nice. This one's alright. Do your best. Maybe use a pencil, especially till you're good at this. Maybe I should be using a pencil still. Okay, y equals cosine of theta. So there we have multiple cycles drawn once again. I've got 5 peaks and 4 troughs again. So that's what it looks like. Okay, if you have any questions, please go ahead and ask. Thanks.